Good morning, Townview. Let's go ahead and get started. Today we're going to be going over the this worksheet right here that discusses the dissociation of water. My students are going to read this. Wolf's kids, y'all are going to have to read this for yourselves. So let's go ahead and take a look at number one. What is dissociation? You should have read it in the paragraph up here. So what is dissociation? What is dissociation? No, we're looking at number one.
What is dissociation?
Yeah, so what is it? All right, please none of that. Let me pause this video.
The particles.
All right, so dissociation is when one molecule becomes more than one molecule. So one molecule breaks down into two or more molecules. So over here you can see with water you start with H2O, and then when it dissociates you're left with a hydroxide ion and a hydrogen ion. So number two, go ahead. What's number two? All right, so H2, so name the two ions that form when water dissociates. You're going to get H plus and OH minus. So what's a hydroxide ion?
When hydrogen and oxygen atoms bond.
All right, you're thinking hydronium. So a hydroxide ion is just going to be an OH minus. What's a hydrogen ion? That's going to be H plus. And then what is a hydronium ion and what is its formula? All right, so it's going to be H3O plus. And how does it form? All right, so it's H2O plus H plus will form an H3O plus. So number 6, next person.
How do you measure for acidity or alkalinity?
Yeah.
You can use litmus paper.
Okay, litmus paper is one way to measure. But what is it that we're measuring? All right, next person, number 7.
They have equal number of OH and OH minus ions.
All right, so they have an equal number of H plus and OH ions. Number 8, next person. Say it again. All right. Number 9, next person. All right. 10, next person.
Digestive fluids are acidic in the body and must be neutralized by buffers.
Must be neutralized by buffers. All right, 11, next person. All right, thank you. And then what is neutralization?
When an acid is combined with base and the result has salt plus water.
When an acid is combined with a base and produces salt plus water. All right, number 1. Next person. What does the paper say?
Oh. Why is the water molecule so important for organisms?
Yeah, do you see what I highlighted?
Maintaining neutral pH so that proteins can work properly without being injured.
All right, that's correct. If you can't read my handwriting, I'm sorry. I'm doing my best. All right, number 2, next person.
What ions form when water dissociates?
What is it?
H plus and OH ions.
All right, good. Number 3, next person.
What is meant by the term alkalinity?
All right.
The measure of the relative amount of H plus and OH minus ions.
Okay. So it's just another word for basic.
Basic?
Basic, yes. Or basicity. All right, 4, next person.
What is produced by the body to help neutralize acidic conditions? Buffers.
Buffers, good. Number 5, next person.
What is the name for OH minus ions? Hydroxide.
All right, good.
What is the name of H plus hydrogen?
All right, hydrogen ion. Next one.
What does hydronium ion form? What is its formula? It forms H2O plus and H2O plus H plus H2O plus.
All right, thank you. Next one.
Eight, right?
Yes.
Why do most proteins either near neutral pH? It's so solutions compared to causing to denature.
All right, good. So they don't denature. Next one.
What two bases form from an acid-base neutralization? Salt and water.
All right, good. All right, H plus or H3O plus.
One, the CO are some of the properties of acids and bases. Fill in the blanks with the appropriate word. Acids A or bases B. A, B, A, C, D, B, E, and F, A.
All right, good. All right, so for this next one, we just need to figure out if it's an acid, a base, conjugate acid, or conjugate base. So I'm going to solve the first one with you, and then I'm going to ask you guys for what you guys put in. So the way I like to do these is we look at the thing, and then we look at it as a product and see what it did. So H2SO4, what did it do? Did it give away a hydrogen, or did it pick one up? So is it an acid or a base? And then NH3 becomes NH4. So did it pick up a hydrogen or did it give one away? So acid or base? Now looking at this side, does H2SO4 want to give a hydrogen away or does it want to pick one up? So is it a conjugate base or conjugate acid? This is a conjugate base. NH4, does it want to give a hydrogen away or pick one up? So conjugate acid or base? All right, so let's go ahead and look at B. So B is the next person, or did we all already go?
I think it's your turn.
I just went.
I think again. A, B, C, A, C, B.
I got that too.
All right, that looks good. And then C, I'm going to give that one for C.
B, A, C, B, C, A.
All right, so H2O gives away a hydrogen, or sorry, gains a hydrogen, which means it's a base. This one gives away a hydrogen, so it's an acid. No, that looks good. All right, so for the next ones, all right, so number 3, I'm going to give number 3 to table 2. That's you right here. So A, go ahead, one of you start.
I minus.
All right, so give the conjugate base for each of the following acids. This is an acid, and we need the conjugate base for it. So what's A again?
I minus.
I minus. So after it gives away a hydrogen, it becomes I minus. What about B?
HCO3 minus.
All right, so HCO3 minus, it gives away a hydrogen, gains a negative charge. Somebody else at his table?
For C, NO3 minus.
He said, bro, he was going.
All right, NO3 minus, last one.
OH minus.
All right, number 4, I'm gonna give this to table 6. That's you guys. Look up here. That's you. All right, so A, we're going from conjugate acid to, or sorry, we're going from base to conjugate acid.
HCN.
HCN, good. Next one. It's gonna become OH minus. What's the next one? NH4 plus, good. Now the last one.
H30 plus.
All right, H30 plus. And now this last part. So this type of question is pretty common on the ACP, where they tell you if you take a strong acid and a strong base, what happens. So I want you to visualize it like this. So over on this side, we have a pH of 0. On this side, we have a pH of 14. And right in the middle, we have a pH of 7. So if we take an acid with a pH of 1 and a base with a pH of 13, and we put the same quantity of each in a mixture, what do you think our pH is going to be? Is it going to be acidic, basic, or neutral?
Neutral.
It's going to be neutral. It's going to meet right in the middle. So it's going to be neutral. Now, if we take a strong acid with a pH of 1 and a weak base with a pH of 8, you mix those together, what's our resulting pH going to be? It's going to be over here somewhere, and it's going to be acidic. What about weak acid, strong base? So you got a base that's 13 and an acid that's, let's say, 6. What's our result going to be? It's going to be basic. It's going to be here somewhere. And then weak acid, weak base. So a 6 and an 8 will produce what?
Neutral.
Neutral. Good. All right, now let's go ahead and look at this last section. On your quiz, you're going to get something that looks exactly like this. Who's finished this table? Hands up if you finished the table. All right, I'm going to give you guys 5 minutes to work on this table. Those of you who haven't finished, 5 minutes, and then we're going to go over it. All right, so what y'all are going to notice when y'all work through these is that if you have a whole number, if your pH is a whole number, without any numbers after the decimal, then calculating your hydroxide and hydrogen concentration is very simple. It's just going to be 1.0 times 10 to the power of your pH. So here where we have 1.0 times 10 to the minus 5, we know that our pOH is going to be 5. If you want to plug that into your calculator, you absolutely should. I'll go ahead and give you the formulas. So up here, it's going to be 10 to the power of negative OH concentration. And then for pH, it's going to be 10 to the power of negative hydrogen concentration. And then for your hydroxide, it's going to be negative log of your pOH. And then this one's going to be negative log of H plus, in case you wanted the formulas. Now, and this should be a minus. Now let's go ahead and go over this. And last thing you need to know is that pH plus pOH equals 14. I'll write that. pH plus pOH equals 14. So if our pOH is 5, that means our pH is going to be 9. Now, because this is a whole number, we could just do 1 times 10 to the power of minus 9. And you're going to see that this does that all the way to about here. And then we start solving the tougher ones, which is more likely what you're going to see on the ACP. I'll do this next one, and then I'm going to leave this. I'm going to ignore the rest of these. But 10, that means our pOH is going to be 4. And then our OH concentration is going to be 1.0 times 10 to the power of minus 4. And this one is going to be 1.0 times 10 to the power of minus 10. Now let's look at this one right here, the 3.2. So because we have our H plus concentration, we should be able to calculate pH. So in your calculator, you're going to do negative log of 3.2 times 10 to the power of minus 3. And that's going to give you 2.5. Now that we have our pH, we can calculate our pOH. So it's 14 minus 2.5, which leaves us with 11.5. And then now that we have our pOH, we can calculate our hydroxide concentration. That's just going to be 10 to the power of negative 11.5, which gives you 0.0316. And then you're gonna need to convert that to scientific notation. That's gonna be 3.1 or 3.2 actually. 3.2 times 10 to the power of what? 10 to the power of minus 12.
Yo, that's a win. Hey, I was recording my phone.
All right, let's move on.
I was recording my phone.
Let's move on. So the next one gives us our hydroxide concentration. With that, we can calculate our pOH. So we're just going to plug into our calculators 10 to the power of, actually no, we're going to do, negative log of 1.8 times 10 to the power of minus. That's gonna give you 13.7 over here. And then 14 minus 13.7 gives us 0.3 for our pH. And then now to calculate our H plus concentration, we're just gonna do 10 to the power of negative 0.3, which gives you 0.5. Or we're gonna do 5.0 times 10 to the power of 1. Negative 1. You're right. All right, next one, 6.78. So first thing we're gonna do is we're gonna calculate our pOH concentration. That's gonna be 10 to the power of negative 6.78. That's gonna give us 1.7 times 10 to the power of minus 7. Or if we wanted to do 3 significant figures, that's going to be 1.66 times 10 to the power of minus 7. And then to get our pH, we're just going to do 14 minus 6.78, which gives us 7.22. And then 10 to the power of negative 7.22. That gives us 6.02. Times 10 to the power of minus 8. And then last one, we just rounded to the nearest 3 significant figures. So for the last one, we're going to start with 14 minus 10.97. That gives us 3.03. And then we're going to do 10 to the power of negative 3.03. That'll give us 9.33 times 10 to the power of minus 4, and then 10 to the power of negative 10.97. That gives us 1.07 times 10 to the power of minus 11. And then to answer if they're acidic or basic, are we looking at pH or pOH? So for this first one, we got 2.5. What's that going to be? 0.3? 7.2? And then 10.97.
Base.
And that's it. If y'all have any questions, feel free to email me, and that's going to be it.